Hello, hi, Assalamualaikum. My name is Muhammad Faiz Farhan bin Rahizam and my number metric is AA201169. Okay, so I want to explain about flip-flop. A flip-flop, also known as a latch, is a bistable multi-vibrator that has two stable states and can be used to store state information in electronics. Signals provided to Alright, next example of application, digital electronic safe box. Electronic digital safe is perfect for securely storing your jewelry, valuables and confidential paperwork. It features an easy to set electronic codes with floor or wall mounting. There is also digital lock, incorrect password, alarm and two backup keys. There is a cash box with tray to keep your valuables and coins in and a crane handle for your convenience. Thank you.
A finite state machine or finite state automaton is a mathematical model of computation. It is an abstract machine that can be in exactly one of a finite number of states at any given time. The FSM can change from one state to another in response to some inputs. The change from one state to another is called a transition. And FSM is defined by a list of its states, its initial state, and the input that trigger each transition. Finite state machines are of two types: deterministic finite state machine and non-deterministic finite machine.
Okay, next, this is our group design for state diagram. Okay, and then next, this is a gamut for question A. FFC, we got a JC equal QB multiply QA bar. For KC equal QB multiply QA bar. And then for FFB, we got a JB equal 1, and then KB we got a equal QA bar plus QC. For the FFA, we got a JA equal 0, and then KA equal QB.
My name is Muhammad Andani Fauzi, Metric AA20774.
And my name is Muhammad Fikri Hakim bin Mustafa. My metric number is AA200111.
And we will present our solution for question B. First, we must make the circuit by using logic. This is our circuit. Next, we will set the input. First, mode operation, line number 1, clear 1, 1, the input D1, C1, B1, A1, and the output will be D0, C0, B0 and A0. For mode operation, clear asynchronous, line number 2. input D1, C1, B1, and A1. The output will be D1, C1, B1, and A1 for parallel load asynchronous. Clear output 1, input D1, C1, B0, and A1. The output will be D0, C0, B0, and A0. For shift right, line number 4, clear 1, input P1, C1, B1, and A1. The clock cost will be 1. The output will be D0, C0, B0, and A0. For line number 5, clock and D1, C1, B1, and A1. The clock pass will be 2. The output will be D0, C0, B0, and A0. For line number 6, clear 1, input D0, D1, C1, B1, and A1. The output will be D0, C0, B0, and A0. And the output will be 2. The input. Line number 6. Clear 1. Input D1, C1, B1, and A1. The clock output will be 3. The output will be D0, C0, B0, and A0. Line number 7. Clear 1. Input D1, C1, B1, and A1. The clock will be 4. The output will be D0, C0, B0, and A0. Line number 8. Clear 1, D1, C1, B1, and A1. The clock output will be 5. Input will be D0, C0, B0, and A0.
For the clear asynchronous, line number 9, the clear is 0, D input D is 1, C is 1, B is 1, and A is 1. Output will be D1, C1, B1, and A1. For parallel load asynchronous, line number 10, the clear will be 1, input D 1, C 0, B 0, and A will be 1. And the output is 1 for D, C1, B1 and A1. For shift right, line number 11, the clear will be 1. Input D is 1, C1, B1 and A is 1. The clock pulse will be C. Output D is 0, C is 0, B is 0 and A is 0. For shift right, line number 12, the clear will be 1. Input D is 1, C is 1, B is 1 and A is 1. The clock pulse will be 7 and output D is 0, C 0, B 0 and A is 0. For shift right, line number 13, the clear is 1, input D is 1, C is 1, B1 and A1. The clock pulse will be 8. Output D 0, C 0, B 0 and A 0. For shift right, line number 14, the clear is 1, input D is 1, C is 1, B1 and A1. The clock pulse will be 9. For the output is D 0, C 0, B 0 and A 0. For last shift right, line number 15, clear is 1, input D 1, C 1, B1 and A is 1. The clock pulse will be 10. Output D 0, C 0, B 0 and A 0. That's all from us. Thank you.